Welcome to the class 2. Today we are going to discuss about how to find the value of a register by using their color codes. So as we know that these are some color codes for register. So black, brown, red, orange, yellow, green, blue, violet, gray, white, gold and silver. These are the colors. And these colors have their own specific values. So let us go by one. The first, I will take the first band here. So this is the first register, which have green as the first band, blue as the second, and red is the third one, and fourth band is a silver one. So as per the chart, we know that is green represents 5, then blue represents 6. So we have to write these two numbers as it is. So it is 5 first color, 6 second color, and red is a 2. So multiplier is 100. So I am multiplying 56 to 100. So it will come around 5600, this much of ohms. Or we can call it as, this is 5.6 kilo ohms. As you know that 1000 is nothing but kilo ohms. With a tolerance of 10%, because the silver color represents the tolerance of 10%. In the same way, go for the second one. The first band is brown, second one is the black here, third one is orange, and the fourth band is gold, which represents the tolerance band. So the first one is the brown. In the chart, you can see the brown represents 1. So I am going to write here is 1 as it is, the first band. Second one is the black. Black is 0. So I am writing as a 0. Third band, that is orange, which represents the multiplier. So orange is nothing but 1000. So I am multiplying 10 to 1000. So that will come around 10,000 ohms. We can call it as a 10,000 ohms, or we can call it as 10 kilo ohms with a tolerance of 5%. Suppose if the register have 5 band code, we have to read it as same as the 4 band code. But only one thing, here I have to add the fourth band value here. Suppose the first one is the blue, brown, white, red, and a tolerance band. So this one, blue, brown, white, brown, and a red tolerance band. So this is nothing but 619 into 10. First code, second code, third code value, and a multiplier. In the same way, we have to go for a second one. Example, I will take red, brown, black, with a brown tolerance. So this will become around 221 and a multiplier of 1. So this will total becomes 221 ohms. So once you know how to find out the value of a resistor, let us go for capacitor. How to find out the value of a capacitor. Unlike resistors, capacitors use a wide variety of codes to describe their characteristics. Physically, small capacitors are especially difficult to read due to the limited space available for printing on it. So how to know the units of measurement for the capacitor? The basic unit of capacitance is the farad, which is represented by capital F. This value is much too large for ordinary circuits. So household capacitors are labeled with one of the following units. So what are these units? So we can write the capacitance of a capacitor by microfarad, which is represented by the symbol called microfarad. So 1 microfarad is 10 to the power of minus 6 farad. If I write it as a m, small m and a capital F, so this is nothing but millifarads, which is nothing but 10 to the power of minus 3 farad. 1 micro means 10 to the power of minus 6. 1 milli, that means 10 to the power of minus 3. Next one, nanofarad. 1 nanofarad. So nanofarad is nothing but 10 to the power of minus 9 farads. Nano means 10 to the power of minus 9. Last one, picofarad. So 1 picofarad is nothing but 10 to the power of minus 12 farad. So remember this. 1 milli, 10 to the power of minus 3. 1 micro, 10 to the power of minus 6. 1 nano, 10 to the power of minus 9. 1 pico, 10 to the power of minus 12 farads. So this is how to read the values. Now, how it looks like. These are the capacitors. On this capacitor, in very small letters, we can read the value of the capacitor, whether it is in terms of a microfarad, whether it is in terms of a nanofarad, or whether it is in terms of a picofarad. So, here it is. This is a small capacitor which we usually call as ceramic capacitor, or this is called cylindrical capacitors. So suppose we have a cylindrical capacitor. On a cylindrical capacitor, the value of a capacitor is given. There is the capacitance of the capacitor is given, that is written. It is a printed one. But if you go for the ceramic capacitor, it is denoted by the number. It is written, the number is written on the ceramic capacitor. It may be 105, it may be 104, it may be 103, it may be 102 or 101. So now to calculate the value of a capacitance of a capacitor which is printed on a ceramic capacitors. Suppose we have 105. 105. So you have to take the first 2 digit as it is. 10. Third one is the multiplier. So it is 10 to the power of 5. 5 represents 10 to the power of 5. This much of picofarad. The ceramic capacitor is always given in picofarad. So if it is a picofarad, then 10, first 2 digit as it is, 10. Third digit represents the multiplier, that is 10 to the power of 5. So this becomes this much of, that is 1,000,000 picofarad, or I can call it as 10 into 10 to the power of 5 picofarad, or 10 into 10 to the power of 5 into picofarad is nothing but 10 to the power of minus 12. So I will write the value of it. So then 10 into 10 to the power of 5 into 10 to the power of minus 12 farad. So this is nothing but 10 into 10 to the power of 7 farad. So here I can convert 10 to the power of minus 7 farad to 10 to the power of minus 6, because I know the value of a 10 to the power of minus 6, which is nothing but microfarad. So I will convert the value of 10 to the power of minus 7 to 10 to the power of minus 6. Then I will rewrite 10 into 10 to the power of minus 7 to 1 microfarad. In the same way, if I go for the number 104, it is nothing but 10 into 10 to the power of 4. The third digit is a multiplier, which is nothing but 10 to the power of 4. So this is nothing but 10 into 10 to the power of 4 into 10 to the power of minus 12 farad. You remember this. So this is nothing but I can write the value as 10 into 10 to the power of minus 8 farad, or 0.1 microfarad. This is nothing but a conversion of a 10 to the power of minus 8 into 10 to the power of minus 6, and then to rewrite in terms of a microfarad. In the same way, 103 becomes 0.01 microfarad. So what about the 102? This is nothing but 0.001 microfarad. So this is how we have to calculate the values of a ceramic capacitor. Once you know the value of a ceramic capacitor or a cylindrical capacitor, we can use the value of it in the calculations or in connecting the circuit. So this is about the capacitor. So once you know the capacitor's value and the resistor value, we can go for a circuits. Now go for some importance of electronics. So here, once you know the values of a capacitor or a resistor or the components which we are using here, active and passive components, then let us know some importance of studying electronics. Let us go by one. The first one. The electronic circuits are used for rectification. What is the meaning of a rectification? Rectification is the method in which the conversion of AC into DC is called rectification, where we are going to convert the input, that is alternate current, into direct current. The conversion of AC into DC is called rectification. This DC supply can be used for charging storage batteries. Second one, we can go for amplification. What is the meaning of amplification? The process of raising the strength of a weaker signal or a weak signal is known as amplification. The process of raising the strength of a weak signal is known as amplification. So for it, we are using a transistors. Rectification, to convert AC to DC, we have to use diodes, a group of diodes, a circuit of diodes. Amplification, a circuit with a transistor, usually a circuit with a transistor. Now go for the next one. Control. Wide application in automatic control, in the controlling the devices. Then the generation. Here, electronic devices can convert DC power into AC power of any frequency. When performing this function, they are known as oscillators. Electronic devices can convert DC power into AC power of any frequency. When performing this function, they are known as oscillators. Oscillators. Next one, we can use the electronic circuits for conversion of light energy into electricity. Light energy into electricity. That is nothing but our photoelectricity. So these are the some of the important of electronics, important of electronic circuits. So now what we have to remember in the calculation after this? We know that electrons is negatively charged particle having negligible mass. So here we have to use some constant values while we are in the calculation, or while we are doing some calculation by using electrons. So charge on an atom is 1.602 into 10 to the power of minus 19 coulomb. Mass of electrons 9 into 10 to the power of minus 31 kg. Radius of electron, that is 1.9 into 10 to the power of minus 15 meter. These are the sum of the constants which are regularly used while we are doing the calculation. So once you know about all these things, let us go for this voltage and the current sources. What are the voltage sources and current sources? So voltage here. Voltage is the pressure from an electrical circuit's power source. Voltage is the pressure from an electrical circuit's power source that pushes charges or charged electrons, that is nothing but a current, through a conducting loop, enabling them to do work. Next, go for the current. Current is the flow of electrical charge carriers, usually electrons or electron deficiency atom. Current is the rate of flow of electric charge, a potential difference, or you can call it as a voltage across an electrical component which is needed to make a current flow through the circuit. So here, voltage sources and current sources. Sources means which provide the circuit, which provide the voltage to the circuit or a current to the circuit. So we have two types of sources here. One is voltage source and second one is the current source. So these sources, one is voltage, one is the current. So further, voltage sources again further divided into two categories. One is called ideal voltage source and a practical voltage source. Second one, the current sources again is divided into two categories. One is ideal current source and a practical current source. So the given sources, that is the voltage and the current sources, are further categorized by ideal voltage source or a practical voltage source. Current sources further categorized as ideal current source and practical current source. So what is ideal sources? What is ideal source? Here it is. We are going to go for one by one. A voltage source. What is the voltage source? It is a two-terminal device which voltage is at any instant of time is a constant and is independent of the current drawn from it. Such a voltage source is called ideal voltage source. Have zero internal resistance. Here, ideal voltage source. The voltage source is called ideal when the voltage at any instant of time is constant. There is no variation of a voltage. Voltage at any instant of time is a constant, and that source must have zero internal resistance. So practically, it is not possible to have a zero internal resistance. So practically, an ideal voltage source cannot be obtained. But the sources having some amount of internal resistances are known as practical voltage sources. Practical voltage sources. Due to this internal resistance,